Yeah, did you guys hear that? Yeah. Wow. I didn't know there's an extra person in the meeting. She's called Siri. All right. Then the second thing I'm going to do is I'm going to share my screen. And okay, here we go. So this Laulima looks a little bit different than your Laulima because it's my super special Laulima. But we still can see mostly the same thing. So we're working with the tests and quizzes. And let's just go ahead and start in order. Okay, so charts and unis. I hope that one was easy for you guys. Did that make sense? I'm assuming that you're all nodding right now. Okay, let's just go ahead. This is the only way I can get into it. So the question was, what is wrong with this chart? And does anybody have any ideas they'd like to put forward?
There's a lot of information. It should be more
Yeah, like
condensed.
way too much information. That was good. That's the right answer. Way too much information. I mean, a chart is supposed to make your life easier, right? And this one definitely does not. Anybody else got anything wrong with that?
There's no title.
Yeah, what is it talking about, right? There's no title, no axes, no orientation, nothing. That's exactly it. So the real thing wrong was it's confusing. And I hope you got the central message that a chart should make your life easier and not harder. Okay. So question number 2. And I also realized I forgot to tell you that your if you tried these assignments, you'll get credit. So don't get upset if you got the wrong answer. This just counts towards your attendance points. So you get points for trying. And let's go turn to the second question is, does this frequency chart match this curve? Why or why not? So here's our frequency chart. And you guys hopefully remember a frequency chart. This is the age. We've got working with, looks like kids from age 6 to 12 and a quarter. And for each value, we can see that their frequency, there's one child that's 6.08, one child that's 6.75, one child that's 10. So there's one child at every frequency. And then the end columns give you the percent. So obviously one child is 3.8% of the sample. This place down here where we've got 2 children, that's 7.7% of the sample. And then the cumulative, the valid percent in this particular case is the same as the percent. But with your work for your projects, you might see the valid percent be a little different. And that's because the valid percent takes out all the people that didn't answer. So whichever one you use, if everybody answered, you use the percent. If people didn't answer, it's more appropriate to use the valid percent. And then the cumulative percent is a nice thing because it'll tell you how many values were under that age. So if I asked you, what was the 25%, 25% of the kids were under what age? Well, you'd go to this cumulative percentage here and you'd see between 23 and 21. So right around here. And you say 1/4 of the kids were under 8 and a third years. Okay, so that's our frequency chart. We get a real feel for what the data look like. And I asked you if it matched the histogram. And it's not perfect, definitely not perfect, but if I had to impose a curve on it, I could do there, and it kind of matches. So the answer was yes, it's close enough. And we have kind of a normal curve here. The highest number of ages are in the middle, and the lowest are at the ends, mostly at the ends. So close enough. I would never ask you something that confusing on the test because it's awfully close. So questions so far? All good? Okay, I'm going to go up to where I can see you. Actually, do you guys know how to do chat in Zoom? I'm talking to nothing. That's okay. Okay, as long as you're learning something. Oh, this is bizarre. Okay, now so that was our first one. Our second one was the bivariate stats. So let's take a look at those questions. Just one question. What type of relationship does this scatter plot represent? Positive, negative, no relationship, or linear relationship? And what do you estimate the value of the R that represents this relationship to be? Okay, so if I had to fit a line to this, remember the last time I told you if I had to fit a curve to it, where would that line go? And that line is technically called the line of best fit. And the computer will figure it out for you, and they'll calculate the distance between every line and every dot. But fortunately, we're just going to eyeball it. We don't have to do it now. And if I had to fit a line, it would go right here. Can you guys see that there? How the line just, if I had to fit a line, it would slope downward. It would start at this value around 600, and then it would go down. So we see that the older drivers don't see the signs as well as the younger drivers. They have to be closer to see it. So because it's got a downward slope, that's a negative relationship. So the distance that it takes for them to stop has a negative relationships with the driver's age. So the older the driver is, I'm sorry, a negative, the distance that they can see the sign from has a negative relationship to the driver's age. So the older people are less likely to see the sign, while the younger people are more likely to see the sign. So if you saw me in person, and I'm going to stop this for just a second, if you saw me in person, I would be doing my little dance. And a negative relationship is when the two variables are the opposite of each other. So when the time they see the sign goes down, age goes up. So the older people cannot see the sign at the long distances. The older people see the sign at the short distances, and the younger people see the sign at the long distances. So that's a negative relationship. If things have a positive relationship, they both go up together. And I think the example I gave in lecture was kids' height and kids' weight. That's got a positive relationship. When height goes up, weight goes up. When height goes down, weight goes down. Can I get some nods? Okay, good, good. This is making sense to you? Good. It's super easy when you think about it. It's a little scary when you attach the word stats to it, right? Okay, so I'm going to put that screen back on. And so that was a negative relationship. All right. So then we're going to go to the stats review, and that was based on my favorite dog, Philip, who's no longer with us. And he was adorable. So he used to really like to come to class. So you might find examples about Philip, little Easter eggs throughout the class. And that was the review. And I just wanted to give you guys a chance to try it more out on a real problem. So I've got the answers prepared right here. There's our tailbone graph with no labels. There's our frequencies. There's our scatter plot. And I'm going to paste that. I'm going to post this online to the module. So if I'm going too quickly, you guys want to see it again, these are the answers. Okay, so that gave you the number of treats per day then that Philip got. And so what you would have to do is you would have to graph them out. And here's a better view of the graph for Lucky Phil. And you can just easily graph that. You got 8 tricks on Sunday, 2 on Monday, 4 on Tuesday, 3 on Wednesday, 3 on Thursday, et cetera, et cetera. Friday, I guess, was a bad day for that poor little guy. But you can see just by graphing that he gets more treats on the weekends. Now, taking the number of tricks he does, which was also included on that information. Sorry, guys, your faces are in the way and I can't put it. We took those pairs, those coordinates, and we graphed them, number of tricks and number of treats. Here he does 1 trick, he gets no treats. Here he does 1 trick, he gets 1 treat. And then here was his best day. He did 15 tricks and got 10 treats. So I asked you what the relationship was between tricks and treats. And we can see, because it's an uphill slope, uphill slopes, see it's a positive relationship. And it's a positive relationship because both variables move in the same direction. More tricks means more treats. Fewer tricks means fewer treats. Tricks and treats. So that's a positive relationship. And then we can also tell, I had one stats teacher who used to call this the cigar. If you took and drew kind of a cigar out around all those points, if it's a skinny cigar, it's a strong relationship. If it's a fat cigar, it's a weak relationship. So this is a relatively strong relationship. We've got an outlier right here, but pretty much a strong positive relationship between tricks and treats. And it's positive again, and I'm going to say this over and over because well, not anymore. It's been about 10 years, but it took me a long time to get over the positive thing. Positive doesn't mean that it's not really a direction. Positive is only the relationship of one variable to the other. So positive just means they both travel together, and negative means that one goes up when the other goes down. So when you see an R value, which represents this relationship here, if it's a plus value, it's going to be a positive relationship. Both go up, both travel in the same direction. And if it's a negative R value, one goes up when the other goes down. Does that make sense to you guys? Okay. So that's the easiest. Because you can get yourself so confused if you don't remember that simple part. So positive just means they travel together, and negative means they travel in opposite directions. All right. Didn't we have any? That was our bivariates. Okay. And I know so you guys, any points at this time? Any questions at this time? You don't have the answer, but I'm going to wait a couple seconds. I want you to write on your paper, what is the largest value that R can possibly be? R is the correlation coefficient. You guys got it written down? Okay, now I want you to write what is the smallest value that R can actually be. Okay, now I'm going to give you the answers. Because R talks about the relationship between two variables, the best thing you can do is have a positive relationship. Is have a one-to-one correspondence, right? So the largest an R value can be is 1, positive 1. The smallest that an R value can be is negative 1. And that's still a one-to-one correlation, but it's that, and I don't want to do this now because Canva makes everything backwards. It's the downward slope. So if you're starting from the axis, if it goes down, it's negative, and if it's an upward slope, it's positive. And I hope you all got that answer right. And if not, write it down, and that should help you study for the test. Okay. Now, we're going to move on to the inferential. And the inferential tests can be a really bit confusing. And as you guys figured out, or you might know that you could have a whole semester talking about the inferential tests. So I really just want you to think about the basics here. All you need to get a grip on some of the research studies you're learning are the basics. And remember how, like a long time ago, maybe it feels like forever ago, that I said that statistics, all statistics do is they tell you whether your result is due to chance or not. Well, how do we know that it's due to chance? We use inferential statistics, because inferential statistics, each value, like a P value and a T value and an R value, all of those are values that we can compare to a distribution of chance. So you know how somebody would say, oh yeah, there's a 5% chance of rain? How do they know that? Well, they know the chances. They look at historical things and they don't know the chances of it happening. So each distribution has a chart that is just based on chance. How likely is this to happen? So when we're inferential testing, we calculate what's really going in our sample. We get a value for our statistic, and then we compare that to the chance value. And our comparison to the chance value tells you how likely our results are to be only due to chance, or how likely they are really there in the population. Questions so far? Is it making a little more sense since I'm talking to you face to face? Okay, good. Thank you for that nod there. Please open the chat and tell me if it's not, because I really want to make sure that I'm helping you. All right, so we've got our inferential stats. And so, like I said, it's comparing what we got to a distribution value, and the distribution value is really based on the chances of something happening. So there's 4 steps to the hypothesis testing. The first one is you start with the null hypothesis. And the word null means nothing. And so you always start with innocent until proven guilty. Start with a null hypothesis, which means you are assuming that there is no relationship or no, let's say no relationship between your variables if we're talking about an R, or no difference if we're talking about a T. So start with the null hypothesis. You start out saying there's no relationship. Then you're going to choose your test statistic. And whatever you choose depends upon what you're asking. And the only ones I would ever ask you about would be a T and an R, because that's as far as we are. So a T value is when you've got 2 groups and you test to see if there's differences. An R value is if you want to measure if there's a relationship. So if you're testing for differences between 2 groups, it's a t-test. And then if you're testing for relationships between variables, it's an r-test. And then with your t-test, you've got one more thing to think about. You want to think, well, are the groups I'm comparing, are they related to each other or not? If they're not related, you do an independent samples t-test, because duh, they're independent of each other. That's pretty easy to remember. Not related, independent samples. And if they are related, it's a dependent samples t-test, because if they are related, they're dependent upon each other. So you choose your test statistic based on what kind of relationship you want to test, a relationship or a difference. And then the third step is you decide on an acceptable level of certainty. And that's like, you're basically saying, what am I willing to accept? Am I willing to accept there's a 5% chance my results are due to chance? Or do I want to be really, really sure and say there's a 1% chance? So a 0.01, that's my alpha level, my acceptance. My alpha level is my level of certainty. A 0.01 means you're 99% sure that your results are not due to chance. So when we say, and when I talk about my lecture, and this is really important, that acceptable level of certainty, that's theoretical. So that's an alpha letter value. And it's a step by itself, because theoretically, we got to say what we're willing to accept before we get it, because we can't say, oh, we found this, so then we're going to decide if it's good or not. No, you got to decide what you're going to accept before you do the test. That's the level of certainty. That's an alpha level. And the really important thing for you to remember about that is that an alpha level tells you the level of chance you are going to accept, but you'll often hear it expressed as the percentage of results are not due to chance. So an alpha is usually values like 0.01, 0.05, and 0.10. Those are usually what we see in research. So that's saying I'm willing to accept that 1%, a 1% chance that my results are due to chance, a 5% chance that my results are due to chance, or a 10%. So 0.01, 0.05, and 0.10 are really our choices for that step 3. So step 3 is super easy, because it's just deciding between 3 outcomes. But the thing that sometimes gets a little bit confusing on this is people will express it both ways. So I want to say an alpha is 0.01. My alpha level is 0.01. Well, I could also say that same thing is that I'm 99% certain that my results are not due to chance. See, that's the same thing. I'm 1% certain that they are due to chance and 99% certain then they're not. An alpha level of 0.05, I'm 5% certain that they're not due to chance. I'm sorry, I'm 5% certain. There's a 5% certain that they are due to chance and 95% that they're not. So because probability always adds up to 1, you know, there's if you add the probability of something not happening plus the probability of happening, always equals 1, right? If it's not going to happen or it is going to happen, that covers the whole universe. So when you see an alpha of 0.01, you also want to automatically think, oh, okay, that's 99% that it's not due to chance. I'm saying 0.01, it could be due to chance, 99 that it's not. When you see an alpha level of 0.05, 5% that it might be due to chance, I'm 95% certain that it's not. So that's the step 3. You decide on an acceptable level of certainty. And then step 4 is you actually take values from your sample and you calculate a statistic out of them. And then we're lucky in this day and age that from that statistic, either a T or an R, as we had talked about, it automatically spits out a p-value. And so it tells you the amount of a p-value, tells you the certainty based on your numbers. It tells you the certainty that your results could be due to chance. So let's say you get a p-value of 0.78 and you had set an alpha level of 0.05. Because the p-value is so much larger than my alpha level, I have to say, no, my hypothesis was not supported. Okay, now I feel really strange about this example because it's so out of context. Does anybody have any questions? Make sense? Or it doesn't make sense at all? I know, you guys are worrying me. Okay, I will also be available for email after this. I've got that paper that explains things a lot. That's this paper. But I'll also be available for email consultations. And it's exactly the same stuff that you guys have been reading in your papers and that you guys have been doing in your lab. Okay, you guys ready to move on? You want me to say them one more time? I'm going to say them one more time because I want to. Okay, because the 4 steps, I'm trying to throw some of this stuff in to explain things to you. But on purpose, I'm not trying to be confusing. And so on the test, I could definitely ask you the 4 steps because they're very concrete. So your 4 steps is you start with a null hypothesis, and that's always that your variables, there's no relationship between your variables, no difference between your variables. The null hypothesis means nothing. And it is often, in most cases, the opposite of your research hypothesis. Because in your research hypothesis, you're hypothesizing, oh, there will be a difference between males and females. There will be a difference between birth order groups. And your research hypothesis, you're saying there is a difference. Well, in statistics, you always start with the null hypothesis, saying there's not a difference. Then you choose your test statistic, and that is based on what you want to know. How many groups do you have? And do you want to talk about relationships or differences? Then you get the easy step, that's decide on your alpha letter, your alpha value, and that's saying, how sure do I want to be that my results are due to chance? So if it's something like a COVID vaccine efficacy of, you want to be pretty darn sure that if you see that it works, that your results are not due to chance. So that would be, you want a really high alpha level, and that'd be 0.01. So you decide on your acceptable level of certainty. That's step 3. And then step 4 is you throw everything in our magic computer. And, or when you were my age, or if you were, when you were my age, when I took stats, we had to calculate all this stuff. So you guys are really lucky. You compare what the computer spits out at you to your alpha, and you decide if it's significant or not. If it's smaller than your alpha criteria, you're glad. You reject the null hypothesis and accept your research hypothesis. Getting clearer? Okay, thank you, Lildenoi. Okay, and then this one is just about reporting. Dr. Irvine conducts a study comparing the scores of males and females on the ability to tell if someone is flirting with them. And that was my actual master's thesis. She reads the numbers below from her SPSS printout. Report the findings in APA style as modeled in the lecture. So when you report APA values, you need to look at a couple things on your printout. And I would just always keep these notes open when you're doing your papers and you look at those. So the number of groups are 2, which we can also tell from the words. There's males and females. The number of participants, that's just N. And then my t-value, which came from the printout, and my p-value is 0.02. So I would report it like T, number of groups by the number of participants, equals report your t-value exactly that is on there. And then the probability is the alpha level you picked, the probability is less than 0.05. So this is how you just write it down. And so anybody that's reading that paper has a shorthand and they know about your sample. They know how many people were in your sample, what the actual t-value is, because if you read these things a lot, that actual value means something. And then the probability, and that's the probability, there's less than 5% that our results were due to chance. Couple things I want to note on here. This p equals 0.05. You can do it either way. I believe the newest APA style wants you to say exactly what the p is. That sounds always so funny talking about p, huh? Tells you exactly. You can report the exact p, or you can report the level that you chose in step 3. And then this t-value, you would generally report the number of participants minus the number of groups, but we're not going to be that picky here. Okay, questions? Okay. So, so this is another one. You're responding directly to a question that we had in lecture, or in our in our online lecture. And I gave you a word problem. And I told you that we did a study on Phil, again, poor little dog. And we had 2 groups, one picture with Phil in front of it. One group looked at pictures of Phil with food in front of him, and one picture where the group looked at no food in front of him. And we wanted to see if he was cuter, which group he was cuter in. So our first step was to formulate our statistical hypothesis, which is our null hypothesis. And that's saying there's no differences, right? Our null hypothesis is nothing. Step 2, choose a test statistic. And because I've got different people, 2 groups, one looks at Phil with food, one looks at Phil without food, I'm going to do the test for differences, which is the t-test for independent samples. Step 3 is to pick your significance level. Remember, 3 is the super easy one because you really only have 3 choices, and the best ones are the small ones. So less than 3. I'm going to say that I'm going to accept an alpha level of 0.05. which means that I want to be 95% certain that my results are really there, that they're not due to chance. And I'm willing to take a 5% certainty, 5% risk that they're due to chance. Then I'm going to compare my significance level alpha to my calculated p-value and report it. So in this case, I state it like we went over in the last example. My T with 2 groups, 30 people in the group equals, there's my T value straight off the printout, 2.06, and my probability is less than 0.05. And because the p-value from the printout is less than my chosen alpha value, I reject the null hypothesis. Because remember, the null hypothesis and the research hypothesis are the opposite of each other. I reject the null, my research hypothesis is supported, and Phil is cuter with food in front of him. So I've only prepared for the stats review because the other is so much easier. So I am done. If you are still confused, please, please, please let me know. You can, I'm going to open the chat box here. I think it's already chat. I think it's already open. Oh, there we go. Good. So I'm thinking, do you get it? Do you get it? Do you get it? Good. You guys get it? Seriously? Or is there some other question? Did you say I'm confused? Downward slope. Okay. Awesome. This, I know what you're thinking. Oh, wait. Yes, that's as far as I can go. Were there questions in here that I need to, any? You guys okay? Okay. Can you guys all please unmute for just a second and give me a temperature check?
I'm good.
You're good, seriously.
I'll read too for familiarize, but listening, that was good examples. And then I can rewatch the video.
Okay, did this, and then I'm also, I've got them in the format I need. So after this call is done, I'm going to put the tests up that you can take as many times as you want. They're completely optional, but you can put them up as many times as you want. And they're the exact same questions that are going to be on the test. So it'll give you 5 per time, but you can just keep taking it over and over and over until you understand, which it makes easier. Okay, so if I have a positive relationship between 2 variables, which way is my slope? Upward or downhill? Is it uphill or downhill? Positive. Uphill, good. If my, I'm looking at a scatter plot and my dots are all spread out, is that a strong relationship or a weak relationship?
Weak.
Weak. Oh, woo. These are making me feel good. It's hard. I think it's just as hard for me as it is for you. I just feel so distanced from you. So hearing you talk and say good answers just gives me a little thrill. All right. Last chance. Please type something if you need something that you need to be explained to you. You guys get, I would not have you calculate. I might ask you for mean, median, and mode. I might put some numbers up and ask you to figure out which one's the median. If I ask that, what would you pick? Median is medium. So it's the one in the middle. That's the way I always remember it. You know, at fast food places, they got like a small cup, a medium cup, and a large cup. Median is medium. So that's right in the middle. Now, if I asked you what the mean was, you would start to calculate an average. And I think I do ask you to calculate a mean, but it's like easy math, like 2 plus 2 plus 4, something like that. And then you always divide by the number in your sample. Okay. You guys have great pictures. I hope that you look as good as your pictures.
You made it sound like the test is gonna, like we're dreading it. And so you made it sound, when you put it in that sense, not so dreadful. No.
No, it's really not. And methods is so hard that way, because I remember the first time I took methods, I took it from this woman who actually, she was a professor and she went to my church, and I was really scared of her because I mean, she was like a foot shorter than I am, because I'm like 5'11". But I was just afraid of her because she was really like everything. And I practically threw up. I used to get stomach so bad. I had no idea what was going on, but I got an A because I just memorized everything. And that was the first time I took methods. And then the second time, it was in my master's program, and it got a little easier. I studied with my friends and stuff started to make sense. So then I took a bunch of methods classes in my PhD program, and all of a sudden it's just common sense. And I know that you guys are probably smarter than I was. We didn't even barely had computers the first time I took methods. So all it is common sense. So you just don't be afraid of it at all. And you can drop a test anyway, right? So I suggest that you take it. Email me, ask your lab instructors. Melissa and Isaac are both really, really good at stats. As soon as I get these tests up, you can take them to study. Yeah, that's it.
Can I ask a question?
Sure.
So for the exam, is the format gonna be similar to the other exams we took? Like, is it multiple choice?
Exactly the same. Same
Okay.
number of questions, same time, same everything.
Okay. Thank you.
Sure. And I figure, that's why I kept the time limit, because I don't want people to cheat, because cheating really isn't fair to other people. So it gives you enough time to take it, enough time to think about it, but not enough time to look it up in your book. I mean, and you can use a calculator if you want. I don't think it's going to make a big difference. You could add 2 plus 2 without a calculator, but if you really want to, that's okay. Yeah, this is more conceptual. Any other questions? And I'm going to post, I've given you an extra week. So I'm going to post the questions, the practice things tonight. And then the test will actually be up on Thursday. And so you'll have Thursday to Thursday, because I figured that everybody needed a little extra time. But you're all smiling in your pictures. So okay. You guys are, I always feel like you guys are like my kids. You're my little hens, my little chickens. And I want you to do well. So please, my little chickens, I'm going to leave you on your own little chicken self. I'm going to press stop on this record. I want you to know that we are all available. And I mean, TAs, GAs, me, we're here to help if you guys have any questions. And you guys can still reach all the lectures, right? You guys can still access all the lectures? Well, we'll find out. Email me if you don't. You guys are a tough crowd. It's a good thing I'm not a comedian. I have no idea what you're thinking. Okay, I will be here. If you have a question, if you're not brave, Lilinoy is brave enough. She'll talk to me. And you guys have.
That's why I'm older than the younger ones, so I'm not afraid.
Isn't that one of the best parts about getting older?
Yeah.
I can't wait. I'm going to be like a really mean old lady when it comes. I'm going to get everything I want out of everybody. First in line. No, I think it's great because you're like, you can get what you need. Thank you. And that was a good thing. I think it's a good thing. All right, guys. 3, 2, 1. I will see you later.
Thank you.
Thank you.
You let me
Thank you
know.
so much.
Let me
Take
know if you guys
care.
need any more help, okay?
Okay.
Bye.
Thank you. Bye.